Be dealing with the double angle identities today. It's still lesson 6.2 because textbook section 6.2 covers all the sum, difference, and double angle identities in one shot. There aren't a lot of examples here. As I said, I want to try to keep this lesson presentation relatively brief so that we get lots of time to practice all of the identities. So there are double angle identities for sine, cosine, and tangent. And you need to be able to solve problems using those identities. Just like the sum and difference identities, the double angle identities are on your formula sheet. And also, just like the sum and difference identities, the ones for tangent are less important than the ones for sine and cosine. So here they are in all of their glory. For sine of 2 times an angle, it happens to be equal to 2 times sine of the angle times cosine of the angle. For cosine of 2 times the angle, there are actually 3. And I want to just explain briefly why there are 3. The one that I typically remember for cosine of 2 theta is cosine of 2 theta equals cos squared theta minus sine squared theta. And I hope you're okay with me just, using theta instead of A or B, because it really doesn't matter what the angle is. Now, first of all, don't confuse that with sine squared of theta plus cos squared of theta equals 1. I mean, they're different identities, right? So just because you see a cos squared and a sine squared doesn't mean it's equal to 1. If you're subtracting them, it's not equal to 1. From this identity, we have learned that cos squared of theta is 1 minus sine squared of theta. So if I go back to the identity on the left, which is the main double angle identity for cosine, I can write cos 2 theta equals 1 minus sine squared theta minus sine squared theta, because cos squared of theta and 1 minus sine squared of theta are the same thing. So what I'm doing is I'm substituting this. There's probably a better way for me to visually show that to you. What I am doing is saying that since cos squared theta is equal to 1 minus sine squared theta, I'm putting 1 minus sine squared theta in for cos squared theta. And the result here, everybody, is that you get a new double angle identity for cos of 2 theta. By the way, we don't put brackets around the 2 theta, but they probably should be there. I just want to look on your formula sheet to see if they do. Yeah, they actually do, so I'm being sloppy. Anyway, you end up with cos 2 theta equals 1 minus 2 sine squared theta. And if you do the substitution for sine squared instead, you get the third double angle identity or you get the second double angle identity for cos 2 theta. And then there's an identity for tan 2 theta or tan 2 alpha. The first couple of examples are just getting us used to recognizing these identities and understanding what they mean. This is very similar to what we did yesterday with sum and difference identities. You look at your formula sheet and you find an identity that looks like this. Is there something on your formula sheet that looks like 2 sine theta cos theta, and if so, what is it equal to? Well, it's equal to sine of 2 theta. And I do realize on your formula sheet, I'll show it to you here, that formula has alphas in it instead of thetas. Boy, that doesn't highlight very well in this PDF reader. But again, I hope you're adaptable. You have to be adaptable. That alpha could be any letter you want. It could be X, Y, R, theta, beta, alpha, omega, whatever. So the bottom line here with this question, everybody, is this is equal to sine of 2 times 15 degrees. it's equal to sine of 30 degrees. If we want to verify it using our calculator, sine of 30 degrees, you probably should not need to use a calculator to know sine of 30 degrees is 0.5, but there you go. If I take 2 times sine of 15 degrees times cosine of 15 degrees, I get exactly the same thing. Let's take a look at B. Again, you were looking for an identity that contains the basic bare bones of this. This is 1 This is 1 minus 2 sine squared of an angle. I'm going to use phi. Which is a Greek letter. It's where phi, phi, pho, fum comes from. I'm just kidding, that's not where it comes from. But it is a Greek letter called phi. And on your formula sheet, you were told 1 minus 2 sine squared of phi is equal to cosine of 2 phi. Well, you're not. You're told with alphas, but again, you need to be adaptable. Which means that 1 minus 2 sine squared 20 is equal to cosine of 2 times 20. And by the way, that's radians, because there's no degree symbol. In other words, the answer is cosine of 40 radians. We can verify that on our calculator by putting our calculator into radian mode. Although, if we left it in degrees by mistake, it would still show that they're both equal. Cosine of 40 radians is this number. 1 minus 2 times sine of 40 radians quantity squared. So that's how you enter sine squared of 40. Gives you the exact same number. Oh, really? How many of you see what I did wrong there? You won't see it by focusing only on the calculator. You have to look at the question. Should be 20. That's right, Amy. It was 1 minus 2 sine squared of 20. Right? That's what we are finding out is equal to cos of 40. So this should be 20. And you get the same thing. One final example here. This one deals with tangent. Clearly, there is something on your formula sheet that says 2 tan sigma over 1 minus 2 tan squared sigma. These tangent ones, I have to look at the formula just to make sure. I don't think there should be a 2 in that question. And I don't know if that's just an error on mine or on your handout. I'm going to look on my handout and see if I fixed it, but I just didn't fix it on my... Yeah, there's no 2 on your handout. So there is something on your formula sheet that says 2 tan sigma over 1 minus tan squared of sigma is equal to tan of 2 sigma. Can you verify that that's the correct identity, what I have written in red? Okay, good. Let me just fix that other thing. So there should be no 2 here. It should just be tan. So what that means is that 2 tan pi over 12 minus 1 over 1 minus tan squared pi over 12 would be tan of 2 times pi over 12, which is tan of pi over 6. And I won't bore you with doing it again. It's interesting. This thing, if you were to bother, if you could be bothered to put it into your calculator, is exactly equal to tan of pi over 6. So any questions with using those identities in that fashion for the first example, A, B, and C? Okay, we have one more example that we're going to be looking at, and this is an XYR thing. Angle A is in quadrant 3, and tangent of A is 5 over 14. So the basic strategy here, since you're asked to find sine of 2A, is that you go to your formula sheet, you look up what sine of 2A is equal to. So I would like everybody to do that and write down what sine of 2A is equivalent to. And you should be writing down 2 sine A cos A because of the double angle identity. By the way, you guys recognizing this, I really hope everybody knows sine squared plus cos squared is 1. Sooner or later, this particular identity in this question is going to become very familiar to you. You're going to start to recognize it. But the bottom line here is you now ask yourself in this question, how do I determine sine of A? And the answer is you take y over r. And how do you determine cosine of A? Well, you take x over r, which means from this statement in the original question, you need to figure out what x, y, and r are equal to. And I'm going to give you guys a minute here or so to figure out what x, y, and r are equal to using what you know about rotation angles and about tangents of rotation angles. And when you have them done, I don't want you to type in what you get. I want you to type in done. Don't worry about anybody else, just worry about doing it yourself, please. While we're waiting for a few other people to type done, is it the case here that you're going to get for r squared a number that's not a perfect square? In other words, if you were to actually take the square root to find r, you'd get decimals. That is true, yeah. Is the number 171? No, it's not. Let me do that again. Is the number 221? Yes. So you're using x squared plus y squared equals r squared. Everybody should be then getting r squared equals 221, which means r is root 221. And I don't believe that 221 can be simplified as a radical. 4 doesn't divide in, 9 doesn't divide in. It might even be a prime number. So we don't have to fiddle around with that. So now I also asked you to figure out what x and y are. So can you start typing in what the value of x is in this situation? Okay, so that's good. Most of you put negative 14, and it is in fact negative 14. Again, this is the equivalent of, oh man, I forgot to factor out B. And I even had some really, really good students on the first assignment. Initially, they forgot to factor out B to determine H. It's a very easy thing to forget. You have to remember that in quadrant 3, which is here, x is negative and y is negative. So how does tangent become positive? Well, it's negative 5 over negative 14, so both of these are negative. Look, we're basically done question 2 right now. And I mean, we're basically done question 2a, 2b, and 2c. Sine of 2a is 2 sine A cos A, so that's 2 times negative 5 over root 221 times cosine of A, which is negative 14 over root 221. The really beautiful thing here, everybody, is that even if root 221 were simplifiable, it's not going to matter because root 221 times root 221 is 221, and then across the top we have 2 times negative 5 times negative 14. I think that's 180, but it's been a long week. I need to know if it's 180 across the top, and that's a 2 out in front, by the way, not that weird thing that I wrote. No, 140. Yeah, 140. I don't know what I was thinking. And, you know, we can be lazy because it's Friday afternoon. If you put 140 over 221 into your calculator to get a decimal and then go math, enter, enter, I think it probably just tells you 140 over 221. I don't think it reduces. Any questions with A? And Aaron's confirmed that. Okay, well, what about B? Well, B asks for cosine of 2a. Well, cosine of 2a is cos squared of a minus sine squared of a. So what's cosine squared of a? Well, cosine of a is negative, I got to go back, I can't believe I forgot that, is negative 14 over root 221. We have to square that, minus, what is sine of a? It's negative 5 over root 221. So I'm going to have to square the negative 14. I want to say 196. And it is in fact 196. So we get 196 over, what's root 221 squared? 221. Minus, I forgot my squared here. When I square the negative 5, I get 25 over, when I square root 221, I get 221. Common denominator, so I have 196 minus 25 all over 221. So we get 171 over 221. Any questions with that example? Hey, don't worry about C just yet. I have one more thing I want to address here for B. So it's 171 over root 221. We can remember that, or I can anyway. You've got it written down so you don't have to remember it. What if you did this? We've claimed that cosine of 2a is also equal to 1 minus 2 sine squared. So we would have 1 minus 2 times the square of the sine, which is negative 5 over root 221. Gives us 1 minus 2 times 25 over 221. I squared the negative 5 and I squared the root 221 just because, you know, it really doesn't matter, even if it were a written question. I'm going to use my calculator here to figure out what that's equal to. 1 minus 2 multiplied by in brackets. I don't need the set of brackets, but that's okay. I get this number. If I convert this to a fraction, I get 171 over 221. Cosine of 2 theta is also equal to 2 cos squared theta minus 1. This would be 2 times negative 14 over root 221. This is the cosine in brackets, squared minus 1. I'll do one more step. This is 2 times 196 over 221 minus 1. So 2 times in brackets, although they're not needed, 196 over 221 minus 1. I mean, those identities all give you the same thing. So which one do you want to use? Whichever one you want to use. There will come a time, maybe in this unit, but definitely in calculus for some of you, where one of these three has a preference over the other. What about tangent of 2a? Now we got to go to that goofy formula. So I'm not a big fan of this formula, but I believe tan of 2a, I'm going to need some verification here, is equal to 2 tan a over 1 minus tan squared of a. Okay, good. So, well, this is even easier because you know what? We were told tan of a. Tan of a is 5/14. This is just a note for me. I just remembered something. So we're going to put 5/14 in for tangent. And again, we're not going to figure out what this is by multiplying top and bottom by anything. These are numbers. This isn't algebra. We're going to take 2 times 5/14 and divide by 1 minus 5/14 quantity squared. I would personally want to do this in 2 steps on my calculator. What I would probably do, this is just because of how I was taught to use a calculator, is I would figure out the bottom first. You'll see why in a second. 1 minus 5 over 14 squared. If I figure out the bottom first, then I can just take the top divided by my answer. If I figure out the top first, then I got to find a way to take my answer divided by the bottom, which is going to involve brackets. You know, in the end, what I would say to you is you just have to make sure that you are able to get, for an answer, 140 over 71. So the correct answer to C is 140 1/71. Any questions with C? All right, let's go back, and I want to talk about A. So what is going to happen? Just stop and think for a second if you were given this question on an exam. And I've got some choices here, A, B, C, and D. And one of the choices is negative 170 over 221. One is negative 140 over 221. One is 140 over 221. And one is 170 over 221. And I will tell you right now, this is from experience, when I have this question on an exam, way too many students end up picking for the answer, even though they've done all of the math we did that you're looking at. They have done all of this. And I see their work on their exam, and then they choose B. And I understand why they choose B. They choose B because they get 140 over 221, but then they look at the question and they say, well, the angle is in quadrant 3. So sine must be negative. Sine is not negative. I'll explain why in a second. But they second guess themselves. They do pristine, golden, beautiful work, and they get the correct answer. This is, in fact, the answer. But then even the sharpest student will say, I must have done something wrong. It's got to be negative. I don't know if anybody's going to figure out what the problem is here, but why is the sine not going to be negative, even though angle A is in quadrant 3? It's a difficult question. Angle A is definitely in quadrant 3. So why is what we're trying to find, which is a sine, not negative, even though angle A is in quadrant 3? It's not because it's a square root. Yeah, I can see why somebody would think that, because, well, maybe the negative goes away or something. So let's be very clear here, by the way. B is not correct. The correct answer is definitely C. Yes, Aiden, it's not angle A, and it's not that the, well, Chloe, that is correct. The negatives do cancel to give you a positive. But in terms of the quadrants, angle A is in quadrant 3. Everybody do me a favor. In your calculator in degrees, you don't even have to be in degrees, I want you to type into your calculator a number of degrees that's in quadrant 3. So everybody should be looking on their calculator at an angle that is bigger than 180 and less than 270. So I'm going to play along as well. If I pick an angle, just a random angle that's in quadrant 3, I'm going to pick 181 degrees. 181 degrees is in quadrant 3. Okay? But we're not finding the sine of A. We're finding the sine of 2A. 2A. So I'm going to double A. If I double A, if I double A, I get 362 degrees. And guess where 362 degrees is going to be? It's going to be in quadrant 1, where y is positive, so sine is positive. Had I picked for an angle 268 degrees, which is almost hitting the bottom of the axis, but it's still in quadrant 3, and I double it, I get 804. Whoops, no I don't. 268, and I double it, I get 536. And guess where 536 is going to be? It's going to end up being in quadrant 2. I'm just pointing this out because you're going to have exams when we get back, and this is one of those things that I get frustrated as a teacher because I don't want students to make this mistake. And when I see students that get 90s on exams making this mistake, don't second guess yourself. The answer is what you get algebraically. So what is your homework for this lesson? It's the 4 attached problems. And then I've got for identities extra practice stuff, this is all textbook stuff. A whole bunch on page 296, a whole bunch on page 306. Take a snapshot of this with your phone if you like, or take a few minutes or a minute or two and write them down. This is what we're working on for the next hour, I guess, right? We started class at 12:30. Yeah, that's right. So we're here for sure for another hour. If you choose to stay past that, I will be here till 3 o'clock. Today's a work day. We have to get practice with this. We'll go over any questions as you have them today, And on Monday, we will go over any questions that you have. Help me out here. Is your next assignment due Wednesday of next week or Tuesday? I mean, I could just look, but I feel as though if I ask you guys some questions, I feel that I'm not all alone here. Monday? Really? Oh, man, let's move it to Tuesday. Yeah, let's move it to Tuesday. I mean, I hope, you're welcome. I hope you understand that, and I'm being very sincere here, my goal throughout all of this crap that we're going through is to try to get you to learn as much as we can in this imperfect delivery. So, and by the way, a few of you have been fishing for help on that assignment, particularly when it comes to C. And I think the only thing I can really tell you is maybe you should redraw that diagram on assignment 3 and put a set of axes in where they belong. And then it might be clearer to you how you can determine the phase shift. The other thing I will say, and I say this only because I got an email right before class, the email was from a student asking if they could approach it from a missing parameter standpoint. And we haven't done that, but if you come up with your equation for assignment 3, I'm almost done here, but you come up with your equation and you have, you know, I'm just going to make something up. Hopefully it doesn't match anybody's assignment. You end up with 8 sine pi over 34 x minus c plus 20. I have to be careful here. And you know that it passes through the point because you're given some points there. I gotta see. It passes through the point 12, comma 28. The person who emailed me just before class said, and I haven't replied to them yet, so this is my reply, and they are here, said, can I put 12 in for x and 28 in for y and solve the resulting equation? So what I'm telling you is yes, except to solve that equation algebraically will be it'll be sneaky. I don't know how much I should show you. If I subtract 20 from both sides and divide by 8, I'm going to get this. And I've set up all of the assignments. I've set up all the assignments, so if you've done things right, that number will be equal to 1. And you do know how to, I think I've given you enough skills that you could solve that equation for C. But I'm not going to go any further. There is an algebraic way to do it. What you've been taught in class is to solve this algebraically is out of the realm of this course, so you solve it graphically. Be careful, if you solve this equation graphically, it's not the graph of the thing you're trying to find the equation of. It's really confusing. So anyway, I'll take the assignment Tuesday. I probably will not get your assignment 2s marked before the end of the weekend. I'll probably try to get at them tonight, but I might just take the evening off. So I am here till 3:30. Sorry, I am here till 3. You are here till 2:30. If you have questions, please, please, please let me know, okay?